So now we're going to move on to angles, angle properties. So an angle is a figure formed by two rays with a common endpoint. Okay, so this right here, I'm going to name this A, B, C. Okay, this is angle 1 or angle ABC or angle CBA. You could also call this angle B, but that's only true because there's only one angle picture. Okay? And what I mean by that is if I had another figure, so I had this figure here, and let's call this D, E, F, G, okay? This right here, I could not call this angle E. Okay, because there are multiple angles. Which angle E are we talking about? Are we talking about angle DEG? Angle GEF? Or angle DEF? Okay, there are three angles there that have your vertex of E. So with this, with multiple angles, cannot name with one letter. So okay, so angle addition postulate, exactly the same thing as segment addition postulate. The sum of the parts of an angle is equal to the whole. And this one as well is part plus part is equal to whole. Okay, so these get a little bit more not complicated, but you have a couple things you need to do with this. So this is if y is on the interior of angle XWZ, and I think that your heads fell off when I said that. So interior is in the inside; it's actually between the rays. So interior inside of the angle between the sides. Okay, so I'm going to draw this. Okay, it doesn't matter. It doesn't have to be to scale, so don't worry about that because we really don't know anything about this angle. So we have angle XWZ, XWZ, okay, and it says y is on the interior. So there's going to be a point y. It's going to be on the inside somewhere, okay, and it's not specific. So there we go. All right. It says the measure of XWZ. So this whole angle right here, the measure is 121 degrees. It also says that the measure of XWY, this angle, is 59 degrees. Okay. Now, one of the things that you need to make sure if you're talking about the degrees of an angle, you're going to write measure of. Okay, if you're talking about the angle itself, you're just going to write angle. So it says y is on the interior of XWZ. You don't have to write the measure of, we're talking about the angle. It's like me talking about you as your name, say your name is Bob, or if I say 5'7", well, I'm talking about the height of Bob, so I'm not talking about the measurement of it. So we're going to use segment addition postulate. I'm just doing this formally. So I know from this diagram, this part plus this part is equal to this whole. So I know that the measure of angle XWY plus the measure of angle YWZ is equal to the measure of angle XWZ. Okay, I know the measure of angle XWY is 59 degrees. I don't know the measure of angle YWZ, but I do know that the measure of the whole angle is 121 degrees. So I'm going to subtract 59. And so the measure of angle YWZ is going to be equal to 62 degrees. And there we go. In your answers informative, you only have to put the answer. You don't have to put the measure of it is equal to. Okay. On the next one, it says the measure of WYZ. So WYZ is equal to 2x minus 5. The measure of XYW, so this side right here, is 3x plus 10. Now, it doesn't give me enough all of the information, but I know that XYZ is a straight angle, and so that angle measures 180 degrees. So we're going to do something very similar. This is going to be the measure of angle X, let's go WYZ plus the measure of angle XYW is equal to the measure of angle XYZ. WYZ is 2x minus 5. XYW is 3x plus 10, and I know that that's a straight angle, so that's 180 degrees. I add this. This is 5x, negative 5 plus 10 is 5, is equal to 180. 5x is equal to 175. Divide by 5, divide by 5. X is equal to 35. It's not 35 degrees, it's just 35. Make sure that you answered the question. The question was just to find X. I found X. Okay. Okay, angle bisector is a line, segment, or ray that divides an angle into two congruent parts, or in half. Okay, so two congruent parts or in half, it's the same thing. So we're going to do this one right here. It says in the diagram, QR bisects angle PQT. Okay, I marked that in my diagram. So Q, it should be the R, this should be QS, bisects angle PQT. There we go. And QP and QR are opposite rays. Okay. It says that the measure of angle PQT is 60 degrees, so this whole thing was 60. And the measure of angle PQS is 4x plus 14. Find the value of x. It should just be value. Okay. You know part plus part is equal to whole, so I know the measure of angle PQS plus, so this one right here, plus the measure of angle angle SQT is equal to the measure of angle then PQT. Okay, PQS, the measure of PQS is 4x plus 14. That's one that I know. PQT is 60 degrees. We are missing this part right here, but it says that since QS bisects this part is the same as this part right here. So this first part, PQS, is 4x plus 14. Then SQT must also be 4x plus 14. So that's going to be 8x plus 28 is equal to 60. Subtract 28. Subtract 28 is 8x is equal to 32. Divide by 8. Divide by 8. X is equal to 4. Okay. It says if the measure PQS, so now it's going to be the same thing, PQS, so this one right here, and the measure of angle SQT, okay, are this. It says find the measure of PQT. It's asking you to find the whole thing. Well, we don't know the whole thing, but I do know that this angle is the same as this angle here. Okay, so this is two different questions for the same diagram. So what that means is I know that because it's bisected, because it says bisect, I know the measure of angle PQS is equal to the measure of angle SQT. So PQS is 3x plus 13. SQT is 6x minus 2. So I solve. 13 is equal to 3x minus 2. 15 is equal to 3x. X is equal to 5. Okay, but did that answer my question? No, it asks what the measure of PQT is. So there's a couple of things that you could do. I'm just going to substitute 5 into either of these and then double it because I know that PQT is equal to that. So I'm going to say, okay, this is going to be measure of angle PQS is equal to 3 times 5 plus 13. The measure of angle PQS is equal to 15 plus 13, which is 28. Okay, and then the measure of angle SQT is equal to 6 times 5 minus 2, which is also going to be 28. And so I know that the measure of angle PQT is going to be the sum of those, which is going to be 56 degrees. And don't forget your degree symbol. Linear pair theorem. So the last thing for today is linear pair theorem. You guys have kind of said this already. Basically, a linear pair are two angles on a straight line, angle 1 and angle 2. This is a theorem because it has to be proven to be true. So I know that part plus part is equal to whole. Okay, so I know that the measure of angle 1 plus the measure of angle 2, and we'll call this ABC, is equal to the measure of angle ABC. I know ABC is a straight angle, so I know the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So therefore, my linear pair, well, what do we know about angles that add to 180? They're supplementary. So linear pair theorem just says linear pairs are supplementary. Okay. So now we're going to do a few problems. All right. I'll actually start with this bottom one. ABC and DBC are a linear pair. Okay, so we'll just do a nice little diagram. So A, B, D, and DBC are a linear pair. ABD is equal to 2x plus 13. DBC is equal to 3x plus 2. What do I know about these? They add to 180. So I know 2x plus 13 plus 3x plus 2 is equal to 180. 5x plus 15 is equal to 180. Minus 15, 5x is equal to 165. Divide by 5, x is equal to 33, I believe. Just make sure, yeah, 33. Okay, but it says find the measure of angle ABD. So I found x first, and then that's going to be the measure of angle ABD is equal to 2 times 33 plus 13. The measure of angle ABD is equal to 66 plus 13. The measure of angle ABD is equal to 79 degrees. And so there we go. Okay, complementary and supplementary. Okay, so an angle is 10 more than 3 times the measure of a complement. Okay, so when we talk about two angles, if I'm talking about two angles, so let's say x is the first angle and y is the second angle. I know because it says that they're that it's a complement. I know that those two angles add to be 90 degrees. It says an angle, let's say x, is equals 10 more than 3 times the measure of the other angle. So I know x is equal to 3y plus 10. So what I'm going to do is, I can't solve this the way it is, but I can now replace this x with 3y plus 10, that additional information. So this is going to be 3y plus 10 plus y is equal to 90. 4y plus 10 is equal to 90. 4y is equal to 80. And in post, I will definitely, y is equal to 20. Okay, and an angle is 10 more than 3 times its complement. Okay, so we found our y value. Now we have to find our angle. How do I find x? Well, x is going to be 3 times 20 plus 10. X is 60 plus 10. X is 70 degrees. And I apologize, I know it's squashed here. I'm going to try and make some more room for this. So for this one right here, since this is 70 and my first angle is 20, well, 70 and 20 is 90 degrees, so I know I've got it right. This is what you would actually put in your answer. Okay. It says find the measure of two complementary angles if the difference of the measure of these two angles is 12. So I'm going to do the same thing. X is my first angle, y is my second angle, and I know x plus y is equal to 90. If the difference of the measures of those angles is 12, well, that also tells me that x minus y is equal to 12. Okay. Now, you may have done a system of linear equations, you may not have, but I want to make sure that right here, instead of having two variables, I have one variable. So what I'm going to do is I'm going to solve this equation so I can substitute the value in here. So I'm going to add y, and so I have x is equal to y plus 12. Well, that's helpful because now I can replace this x with y plus 12. Okay, 1y plus 1y is 2y. Plus 12 is equal to 90. Plus 12 minus 12. 2y is equal to 78. Divide by 2, divide by 2. Y is equal to 39 degrees. Okay, now it says that the difference of those angles is 12. So I know, here's my one angle, I know x minus 39 is equal to 12. So if I add 39 to each side, well, my other angle must be 51 degrees. And is 51 plus 39 equal to 90? Yes, it is. So that's that.